Tristan, we're on page 45.
Okay, thank you.
Okay, so it says consider the equation 5x minus 2y equals 3. If possible, find a second linear equation to create a system of equations that, number one, has exactly one solution. So what does it mean when a system has exactly one solution?
It
Has
has one answer.
one answer.
It's an ordered pair.
It's an ordered pair.
It works out. I don't know, but it's on a specific point in the graph.
Okay, it's on a specific point on the graph. What specific point on the graph is it if we have two lines?
Where it intersects.
It's an x and a y. Yeah, it's where the two lines intersect. So what do we need to do? What do we need to know about our equation to find a line that intersects it at some point? What can we do?
We can substitute it into each. Wait, I'm sorry. Can you repeat that, please?
Yeah, so what do we want to know if we're going to find a line that crosses our line at any point, at one point? It can be any point.
That's multiple solutions. Infinitely.
That's when every line works, every point works.
Oh, you're asking. Wait, what are you asking?
So we want to find a line that has one intersection with our line, 5x minus 2y equals 3.
Oh, you want us to tell you how to solve it?
Yeah.
Oh, then you can put it in slope-intercept form. and
Okay.
solve for it.
So how do we move this into slope-intercept form? We can do that.
Add the 5x.
Yeah, we subtract the 5x. Okay. Then what would I do? I'd by -2.
Can you grab me a calculator? Thank you.
We have to put it in the fraction, or does it need to be like -1.5 plus 2.5x?
Yeah, you can have it as decimals too.
Would you suggest fraction?
Oh, I'm sorry. I thought you were here.
Fraction can be easier on a graph because when you're doing slope, you can have rise over run.
Okay.
So that fraction is sometimes easier. Okay, now we have it in slope-intercept form. And we want to have one point on the line that another line crosses through. How can we find one point on this line? Just one. What
-3/2 would be the b, right?
would be the y-intercept? Yeah. So Tabitha said that our y-intercept is 0, -3/2. Right? So how can we use that to write another equation? We could substitute it in. So we're going to want another equation that looks like this. If we want our second equation to go through the point 0, -3/2, how could we figure that out? We have an x and a y in our point. This is our x and this is our y. Do we have an x and y in our equation? Y equals mx plus b? Yeah, I see this is a y and this is an x. So I'm going to plug in our y and our x. So that tells us that if we want another equation that passes through our y-intercept, we want to have our y-intercept be the same on our next equation. So this is all kind of arbitrary, right? We can pick any x and find a point for y. Does it matter what our slope is? It kind of matters, it kind of doesn't. What could be a slope that we could use that would only cross one time?
0. Wait, what did you just ask?
I
You
said,
it only crosses one time.
so we have this, our y-intercept is -3/2, and we want it to cross our other line only that one time, only at that one point. So what would our slope be?
Don't we need to solve for it?
We could solve for it, but we can also just pick a slope.
Just anything? 3.
Just about everything. So you say 3?
Mm-hmm.
Yeah, that'll work. That's our first line. We see it's crossing at that -3/2. And so we put 3x minus, 3 over 2. That's only going to cross once. So our slope could be just about anything. But let's talk about this next one. So we have an equation. We could have pretty much infinitely many equations that'll have one point in common. This is just the one we found by using our y-intercept and then picking the slope of 3. So let's look at the second one. Exactly 2 solutions. If we have one line, our fx minus 2y equals 3, is there ever going to be another line that crosses it twice? We have a line. Would we ever have a line that could cross it twice? No. To have 2 solutions, we'd have to have something that looks like that, like a parabola or something. But they asked us for a second linear equation. So that one's a little bit of a trick because it's not possible to have exactly 2 solutions. Because if we have 2 lines, they're only ever going to have that one intersection. What does it mean for lines to have no solutions? They don't intersect. What's another way to say that 2 lines do not intersect?
Parallel.
They're parallel. So these are going to be parallel lines. How can we write an equation that's parallel to this one?
Don't you just change the b?
Yeah, we just changed the b. We're going to have the same slope, but a different y-intercept. So we'll keep our same slope. What's a y-intercept? 5. Yeah. We can choose 5. You could choose 1,000. You could choose -2. All of those would be possible equations as long as that slope is the same. All right, and the last one says infinitely many solutions. What does it mean to have infinitely many solutions? Yeah, they're going to be pretty much the same line. So how could I rewrite our equation that would mean the same thing but look a little different? Could I add something to it, multiply something, divide, subtract?
Multiply the whole equation by 2.
Yeah, multiply the whole equation by a number. So we have 5x minus 2y equals 3. Nasiba said, why don't we multiply the whole thing by 2? Oops. Now we have basically the same line, but it looks a little different. So if I were to really quickly solve this for a y equals mx plus b form, it would end up simplifying to the exact same equation. We'd have the same slope and the same y-intercept. It just looks a little bit different. What questions do we have about this whole problem before we move on? So when we have one solution, we have two lines that cross at one point. If we have two lines, we can't have exactly two solutions because one of them would have to bend. No solutions is when our lines are parallel or they have the same slope. And infinitely many solutions is when they're just the exact same line. But
They have the same slope. They just have a different. I thought you switched the slope.
for no solutions?
Yeah.
For no solutions, the lines are parallel, so they have the same slope but different y-intercepts. Okay, we're going to turn in our books back a couple pages to page 42. Page 42. So, it says the only coins that Alexis has are dimes and quarters. Her coins have a total value of $5.80. She has a total of 40 coins. How many does she have of each coin? So what do we know in this problem? What do we see?
We see that she has dimes and quarters. She has a total value of $5.80, and she has 40 total coins. So you can set up two equations for it. You can set up an equation for how many coins she has and how much money she actually has.
Okay.
And you can use two different variables like D and Q for that. And you know, dime is 10 cents equals 10 D, and 0.10 D and 0.25 Q equals 40.
Okay.
No, because
Tristan,
that would be the-
all of what you said is absolutely right. I'm going to walk through it step by step. Okay, thank you. So we have dimes and we have quarters. Those are our two variables. And Tristan told us we're going to call our dimes D and we're going to call our quarters Q. And we noticed we have a total of 40 coins. Yeah. Okay, so we're going to have two equations. One is going to be for the number of coins. Okay, you can't see that green. It's going to be the number of coins. And one is going to be the amount of money.
So you equal the dimes and quarters to the money.
Okay. Yeah, so we'll have dimes and quarters in each equation because we have two variables, dimes and quarters. If we have a total of 40 coins, how do I combine the dimes and the quarters? Yeah, we add them. So we're going to have D plus Q equals what?
40.
Equals 40.
And then you do the actual variable, the actual amount of the dime and the quarter.
Yeah, and then we'll write our second equation for money. And Sean, this is what you were saying, is that we have 10 cents for each dime. And since we have, yeah, so that'll be for quarters. For dimes, we have 10 cents per dime.
And then you can solve like with elimination or substitution or graphing.
Yeah, exactly. So now we have two equations. They're linear equations. And we can use them to solve for our variables. So, what looks like the easiest method to use?
Elimination.
Elimination or substitution?
Wait, elimination is when you multiply it by one thing and then eliminate.
Okay, we can do elimination. If we did substitution, FYI, we would just move that Q over and have a value for D and then plug that in. But we can absolutely do elimination. So what would I have to multiply by to eliminate one of our variables?
You can multiply everything by -0.10.
Okay. Multiply everything by -0.10. And now I have
-1.
So what do I do now? What's my next step to solve?
You cancel out the tens.
Okay,
Or
so
the point tens.
I'm going to add everything together and my D variable will cancel out. Then when I add 0.25Q and subtract 0.10Q, thank you, I get 0.15Q equals
Equals 180.
On the other side we have, oh yeah, okay, so you got this one and now we're on this side. So 5.8 minus 4 would be
180.
1.8. What else do I need to do to solve for Q?
Divide by 0.15.
Okay. Does anyone have their calculator and can find that value?
It's 12 quarters.
Should be 12 quarters.
Oh no.
Okay.
Then you can substitute Q back in and just subtract 12 from 20 and get your answer for how many dimes.
Absolutely. Okay, so Tristan wants to substitute Q in over here. So we're going to write D plus Q equals 40. Subtract 12 from both sides. And how many dimes do we have? Oops, that is a...
20.
We have 28 dimes. So Alexis has... Alexis has 12 quarters. And she has 28 dimes. Does anyone have any questions about how we got 28 dimes and 12 quarters? Okay. If we don't have any questions, we're going to move on to the second problem. This one looks pretty similar, but is a little bit trickier. What do we notice first?
The digits of the two-digit numbers.
Okay. So how would I write that as an equation? Sum of a 2-digit number is 7.
2x. Is it 2x plus, wait, 2x plus 7?
So,
It's a sum.
yeah. Okay, so Nasiba said we're going to write, that doesn't show up. We're going to write x plus y equals 7.
Oh, yeah, that's not bad.
So we have a 2-digit number. Our 2-digit number is xy. So if we had, 34, we're just going to call our number xy. And when we added those together, we got 7. So that's our first equation. That's what this is telling us. The second part says when the digits are reversed, the number is increased by 27.
Is that 34 or 34?
So, here, I'll rewrite it. So we're going to call our number xy. So for example, if our number was 34, or we could pick any number, if we wrote 36 as our number, I would say that the 3 is x and the 6 is y. So we're calling it xy. That's together. So our number is called xy. When the digits are reversed, the number is increased by 27. What would it mean if our numbers were reversed? Yeah, they're switched around, it would just be yx. So we're going to this number, to yx. What does the x represent here? What place is it in?
I'm sorry, can you repeat that again?
What does the x represent in this number? What place is it in? It's in the tens. So does that 3 just mean a 3?
No, 30.
It means it's 30. So what did we do to represent how much the 3 was? We did 3 times 10 equals 30, right? So this x doesn't just mean x because it's in the tens place. So if I did 3 times 10 equals 30, what would I need to do for that x?
4. 0 plus 4.
So,
Oh, wait, x, sorry.
so this x is in the tens place.
You divided by 10.
So this x is in the tens place. And we just said for this 3 in the tens place, that doesn't just mean 3, it means 3 times 10 equals 30. My x is taking the same spot that the 3 is. What would I need to do for the x? It's in the tens place. In our tens place, it means not just 3, but 30. What did we do to that?
Oh, you multiplied like.
Yeah, we multiplied it by 10. So in the tens place, whatever that is multiplied by 10. So it's 10x. What about the y? Is the y just a y?
No, it's 4. Well, it's in the 100. No.
So the y is in the ones place.
Sorry.
And you're right, down here, the ones place is 4.
So it's just 0 plus 4.
So it would be, what did we use for the tens place? What operation? Multiplication?
Oh, so
And it would be
1 times 4.
just 1 times 4, yeah. So when we have our y,
You multiply by 4.
We multiply
By one.
by 1. Okay, and then we're talking about the sum of these two digits, x and y. So how do we connect 10x and 1y if we're talking about its sum?
You multiply.
No, we add them.
Yeah, we add them. What does sum mean?
Adding.
Yeah. So this is going to be the same as our number xy. Because x is in the tens place, and when we add it to that, y in the ones place. So if we did the same thing for the reverse number, what do we do for that y? What place is it in? By 10. So now the y is in the tens place. So we have 10y. And what about the x? Where's that now? That's So now that's 1 times x. And again, we're talking about the sum of these two digits. So we combine them with addition. Now, what is the difference between our numbers when we reverse them? When the digits are reversed, what does it increase by?
27.
By 27. So when I go from xy to yx, what am I doing?
Increasing by 27.
Increasing by 27. How do we represent increasing by 27?
Plus 27.
Add 27, yeah. There's a difference of 27. So from xy to yx, that's when we are reversing the digits. There's an increase of 27. I'm going to now rewrite what we have for xy all together. And I'm going to write 10x plus y plus 27, because we're increasing by 27, equals 10y plus x. Does everyone understand how I went from here to here? What questions do we have about that?
You just added the 27 and
Yeah.
then set the other one equal to it so you can figure out what the new numbers are. Yeah.
So we said 10x plus y represents our digits in the first way, and then we add 27 because we know it's increasing by 27 when we're reversing them. So that was the tricky part. Now what do? We have two equations. We now have two equations. We now have our system of linear equations. What do we do now? Yeah, we're going to solve them. How do we solve them?
We add the 27 to the
What are the methods we have for solving systems of linear equations? That's what we've been talking about the past few days.
we can do like elimination or substitution.
We can do elimination or substitution. Which one seems easier here?
Elimination.
Elimination seems easier with these two equations.
Which one seems easiest? Yeah, that seems easiest. Elimination, because you can just multiply the x by negative.
Okay. You are very bold. I'm going to use substitution here.
Whoa, you mean in the original? Wait, where did you get the x plus? Oh, you said this. Oh, okay, yeah. I'd substitute them too.
Okay.
So I forgot that was the original.
Okay, so we have x plus y equals 7 is our first equation. And then this whole big mess is our second equation. So if we want to substitute, how can we change this first equation to help us substitute? Subtract y. Great. So we're going to end up with 7 minus y equals x. So I'm going to take this whole part, 7 minus y, and substitute it in for x. Now what variable do we have in that equation?
Negative 10 y.
Oops, I forgot that y.
Oh, I think I did this wrong.
Wait, hold on, I forgot a y. Yeah.
Oh, I used what's the step.
Okay,
You multiply the 10 instead of 7 minus y.
great, I will distribute my 10. Now I have 70 minus 10y.
Plus y plus 27. But you can combine my 10. But
Okay.
you can do that in this.
Okay, thank you. Plus 7 minus y. Okay. So Tristan says let's combine our like terms.
Negative 10 plus y is negative 9y.
Okay, and what about our other like terms on that side?
70 plus 27, that's 97.
And on the other side, 10y minus y
9y plus 7.
plus 7.
And then now you can add 9y to the other side.
Okay, I'm going to add 9y.
18y plus 7 equals 97. Then you can subtract the 7 from the other side and get 90 and then 18y. And then divide by
Okay, hold on 1 second, Tristan.
Sorry.
You're on the right track. 90 equals 18y.
And then divide by 18
Okay, now we're going to divide by 18,
and get 5.
and we'll get that. Oh, sorry, you can't see that. I'll just move it over there. If you ever can't see that, just let me know. So we have y equals, you can't see that either. Y equals 5. Is that what you said?
Yes, ma'am. And then you can substitute it back into the original equation.
Okay. So we will be substituting it and finding x. What does y represent?
It represents our 10's value.
It's in our first number, it'll be that second number, that second value, digit. And in our second number, it'll be the first digit. So Tristan says we will substitute it back in. That's, give myself a little box there. We're running out of space. We say x plus 5 equals 7.
Which is x equals 2. If you don't want to show the work, I mean, I think everybody can do
Which
that.
is x equals 2. So, if our x equals 2 and our y equals 5, what is our first number?
It's 27.
Oh,
Oh, golly. Isn't it because...
so our x is y, or our x is 2, and our y is 5.
Oh, 25.
So we have
Sorry,
25.
I did it wrong.
And what's our second number when we reverse it?
52.
Our second number is 52. Does this make sense? Do we have 2 plus 5? What does that equal? 7. So we knew that our numbers added together equals 7. Does that work for the second number? 5 plus 2, same numbers. How much are these increasing by? What's the difference between these two?
27.
Did we check it? Do we believe it? Okay. So that was a lot at once, but that's the problem-solving process we would take to do that. So, that is all we're doing today. You had a homework that was due this morning, but you should go back and look at it. No points off for late work. Always make sure to go back and look at it. And if you have your permission slips, you are welcome to turn that in.